Right, so welcome to this video on the 2016 question 6 higher level technical graphics. Alright, so figure shows the child's piggy bank. The curve ABCD is an ellipse and point B is on the curve. Determine the length of the major axis and draw the ellipse. I'll put that into focus now. So what I'm thinking about is, what do I know, alright, about drawing ellipses, okay, and what information do I need, right? So I know if I have the major and minor axis, okay, I can divide up my divisions, or divide my circle into divisions where the division line touches the major circle parallel to the minor, where the division line touches the minor circle parallel to the major, and where they intersect is the point in the curve. I know if I had F1 to P, a point on the ellipse, and F1 to P plus P to F2 is equal to the major, so I could plot those distances out, find half of it, okay, and then you get your major circle, and then to get the minor, could take half the major and swing from the focals to get it. So I know that, and I know if I had my major and I had my focals F1, F2, okay, to find the minor circle, as I was just saying there, is I could take half the major and swing from the focals. I don't have the focals here in this question, okay, I have point B and I have the minor radius, so I'm going to use this working backwards from the concentric circles method. So to do it, we're going to draw in our minor circle. We're going to plot out point B, okay, we're going to go parallel to the major axis AD. Now, where this line touches the minor circle, we're going to draw a sloped line through that one, a division line, and then we're going to go parallel to the minor axis, and where they intersect is a point then on the major circle. So that's the point then on the major circle, and then we can divide it up, right? So I'm going up 22 from the base, and then a further 55. Further 55, so 117. So that's my center point of my minor circle now. I'm going to draw in my minor circle. So that's point C and E. Now to find point B, I'm going over 60 and up 40. There's point B now. Okay, so remember that's the major axis, that's the minor axis. So I'm going to go parallel to the major axis from B, and where it hits the circle, that's a point on the division line. So I'm going to draw a sloped line through that. Then from B, I'm going to go parallel to the minor axis until it hits that division line there, right? That's a point on the ellipse there. Or sorry, not a point in the ellipse, a point on the major circle, right? So I'm going to draw in my major circle. Now I'm going to divide the whole circle into 60, 30. Now, where the division lines hit the major circle, the big one, we're going to go parallel to the minor axis towards the major axis. So I'm going to go parallel to the minor axis towards the major axis. Same over here, we're going parallel to the minor axis towards the major axis. Then where the division lines hit the minor circle, I'm going parallel to the major axis away from the minor axis. Now, here are my points on the ellipse. So I'm going to pause and lightly freehand sketch them in. So is that part done, sketched in? Okay, now the lines PQ and RS are tangents to the ellipse from points P and R. So it's the tangents from outside. It's a tangent to the ellipse from a point outside the curve. Alright. Now look, the particular year group I've done this video for, I may not have reached tangents from a point outside the curve in class, but however I'm going to still do it. So I'm going to have to measure out 110 for P and R. I'm going to have to go up 20 and down 20, and this is our points P and R. Now, in order to do a tangent, I'll need the focal point. So a reminder, right, how I'm going to get the focal points, okay, is we know that if I F1 to P plus any point on the curve, alright, it's F1 to any point on the curve plus that point P to F2 is equal to the length of the major diameter, so the distance between V1 and V2. So here's an example of F1 and F2. So F1 to B plus B to F2, those what you call it, two together, added together, equals the length of A to D, the major diameter. So if F1 to C and C to F2, these two lines added together have to be the major diameter, so each line must be half the major diameter. Right, so if I want to get the focal points, I'm going to take half the major diameter, okay, and I'm going to swing it from the top of the minor. That's going to get me the focal points. So I'm going to do that right now and then show you the rest. So I'm going to take half the major and swing from the top of the minor circle. So F1, F2. Now back to the ellipse there, right? So once I have the focal points, right, what I need to do is I need to join P to F2, or the nearest focal point essentially, and I need to extend the line on if I remember correctly, I'm going to take my compass, put my compass on P and swing a circle from F2. Swing an arc really is all you need. And then, okay, I'm going to get the distance between V1 to V2, and I'm going to swing from the focal furthest away. So I'm going to swing two arcs from, or I'm going to swing one arc from the focal furthest away, and then where they intersect, I'm going to join them to F1 and F2. Oh well, I mean, I don't need to do the one at the bottom, because that'd be both of them to F1, that'll give me the point of contact for, or that'll give me a tangent from another point outside the curve, so I don't need to do that. For the bottom one, I just need to repeat the same strategy from OR. So I bring OR, put my compass on OR, and do the same. So I'll just do one at the time being. So I need to go out 110. So go out 110, then we'll be going up and down 20 for the points P and R. P or so I'm going to join P to F2. I'm going to swing an arc from P to F2, and then I'm going to take the distance of the major diameter and I'm going to swing from F1, and where it intersects, where they intersect, I'm going to join them to F1, and this is point Q here, so that's point Q, so that's where my tangent is going to be. So there we go. I'm going to repeat the same strategy from OR. So the radius is going to be identical. So it is. So I can swing. I swung one arc up there. While I have the compass set, I can swing a radius down there. Now I'm going to set the distance from OR to F2. Swing an arc down there. So that's the radius of OR to F2. And a reminder that this one here is the radius of the major. Your compass is set to the length of the major diameter. You swing from F1. Now where they intersect, join back to F1, and then join this point to R. If you're under pressure in the exam for time, I'd say, because they're identical, you could just drop 1 point down. So you could say that would be alright. Now for a little snout then, in 10. We'll look at what else we have to do then. So, I skipped what you call a KMN, the parabola, the vertex at M. Sorry for doing that the opposite way around, but it's not a problem. Right, so I went up. Did I go fucking 20? Oh. Now, I accidentally said earlier that I went up 22 when it was actually 20 from the bottom. So I'm actually just going to drop down 20 here. My apologies. And I'm going to redo that. Now, the width of the parabola is 54 in total, so we're going to do the rectangle method of drawing that, and the height is 42. So no number is coming out of my head that divides evenly into them without doing the division of lines method. So I'm going to just split each one up into 3, draw a line at any acute angle, mark 1, 2, 3 equal marks in it, join back to the corners here. All the lines are parallel. 1, 2, 3. And then there's your points and mirrored across. So 54 divided by 2 is 27. And then the height we're going up is 42. So we'll draw a line at any acute angle. So I'm going to draw a line here. I'm going to mark 3 equal divisions on it. 3 centimeter, or every 1 centimeter. So these join to the vertex, and then line at any acute angle, so I'm going to mark 60 here. Just it's easier bringing it back that angle. Doesn't make a difference though at the same time. There's the vertex, you can mirror them over. And then freehand sketch them in. So that's that done. The rest then, the circle, join D to right, this will be a bit of crack now to find what you call it, this circle here, right, okay, we got it, right, so across from B, straight up from N, join to D, where it intersects the minus circle, radius 8, then this arc then, okay, where they intersect over 24, join the centre point to this, what you call it, vertex of the minor circle, draw a line from E through that centre point there. This is the portion of the curve, the sector of the circle. Then the tail there is fairly obvious, up 14 from B, draw a line. Then this arc here, radius 55. To get that point there, pretty sure it's just where, straight down from this centre point here, or might possibly be where, we'll see it on the drawing, it might be where the line RS, it's basically where RS is a tangent, it's the point of contact really, point of contact between line RS and the ellipse. Okay, so I'm just going to get a pen. I'll go right. So we're going straight up from N. This is a light line for you guys, the one I'm doing in pink. Straight up from N, I was saying then we're going straight across from B. So where they intersect, okay, we're going to join back to a vertex on the major circle. I possibly said minor circle earlier, major circle, sorry. Okay, now there's the center point for the radius 8 circle. Okay, then we have to join point E here through this center here. So that's a light line. Okay, now radius 24, radius 8 circle. And I also have to join this point together, these 2 points. So this is the ear here, then the radius 8 circle is here. The eye, then radius 14 circle, so up 14 from B, for its tail. Then for its legs is the 2 arcs down at the bottom, radius 55. And the same over here. Right, now I'm going to pause and heavy all that in to show you what it looks like when it's done. And there's the question done. Cheers, thank you, bye bye.